All right, so finishing up with the rest of the question, it's asking us to find the magnitudes of F2 and F3, and it gives us the magnitude of F1. What I really like to do is write down all the information that I know. Once I have all the information in front of me, it makes solving the problem a lot easier. The first thing we know is that F1 is 12 newtons. We also see that this is a 45-degree right triangle, so we can assume that y1 is equal to x1. Now going down to the bottom, we see that it's a 60-degree right triangle, so you can write in here that this is 30 degrees. Another thing we can see is that there are only two factors in the y-coordinate, y1 and y2, both in different directions. Because we know that all the forces need to cancel out, we can deduce that the y vectors also need to cancel. This means that we can write y1 plus y2 will equal 0. And this could basically be rewritten as y1 is equal to negative y2. Another thing that we can see is F3 only has an x-coordinate, and we can call that x3. So given the x1 and x2 are in the same direction, we can deduce that the sum of x1 and x2 must cancel out with x3. We can essentially write x3 is equal to x1 plus x2. So with all this information, we can begin using our knowledge about trigonometry. The first force that I would find would be F2, and this is because in order to find F2, which is the hypotenuse of the blue triangle, we only need one side of it. At that point, we can use trigonometry. And we've concluded that y1 is equal to the negative y2. So if we're able to find that value of y1 on the red triangle, we're able to eventually find F2. F1, which is 12 newtons, is given, and we're also given the angles for the red triangle. So to begin by finding y1, you would just use sine of 45 equals y1 over 12 newtons. Rearranging that will give you 8.5 newtons. With that number, we can also conclude that y2 would be equal to negative 8.5 newtons. So now we would write cosine of 30 is equal to negative 8.5 newtons over F2. Now, rearranging that will give us negative 9.8 newtons. Keep in mind, the question is asking for magnitude. The answer we have here with the negative indicates the direction of F2, which is going downwards, which is why you see that negative. So if we're purely talking about the magnitude, F2 would just be equal to 9.8 newtons. All right, so we found one force. Now we need to find F3. So with your knowledge about 45-degree right triangles, we know that the legs and the arms are the same value with only the hypotenuse as a different value. So because we found out that y1 is equal to 8.5 newtons, x1 is equal to 8.5 newtons. Now with this value, all we need to do is find x2 in order to find the sum of the two values in order to get x3. So again, with x2, it's just another trig equation you have to set up. There's many directions you can take. You can use tangent or you can use sine. So I'll go through both paths so that you guys have an idea of what both of them are like. So using the sine method, sine of 30 would equal x2 over negative 9.8 newtons. So rearranging this, you would get negative 4.9 newtons. Now let's use the tangent method. You would set it up as tangent of 30 is equal to x2 over y2, which previously determined to be negative 8.5 newtons. Rearranging this will give you negative 4.9, and there is a bit more numbers, but you can pretty much just round this to that. As you can see, both numbers are pretty much the same. So now that you have both x1 and x2, all you have to do is get the sum. x1 plus x2 would equal negative 8.5 newtons plus negative 4.9 newtons. At this point, you kind of have to understand that you can't just add the negative values together. It'll give you a wrong answer because the negative sign in this case does not really mean a negative number. It is indicative of the directions of those values. F1 and F2, they're in the same direction. You would add the magnitudes of them together. These values would be negative 13.4 newtons. Now, since x3 is the opposite of x1 and x2, x3 would be a positive 13.4 newtons. We can conclude that the magnitude of F3, which is only composed of the x coordinate, is also 13.4 newtons.